Hello again, this is Mr. Liao, and this is the second combined FRQ review for 2020. We'll start with 2014 number 2. 9 sales reps, 6 men, 3 women at a small company wanted to attend a national convention. There were only enough travel funds to send 3 people. The manager selected 3 people to attend and stated that the people were selected at random. Just so happens the 3 people selected were women. What a coincidence. There were concerns that no men were selected to attend the convention. Part A, calculate the probability that randomly selecting 3 people from a group of 6 men and 3 women will result in selecting 3 women. So what you're going to want to think about is what's the probability of the first person being selected is a woman, then another woman is selected, then a third woman was selected given that the first 2 women were selected. So the first woman's probability is 3 out of 9. After the first woman is selected, 2 out of 8 are women, and after the second woman is selected, only 1 out of 7 is women. So multiply 3 9ths times 2 8ths times 1 7th, and the probability of getting 3 women at random is 0.0119. B, based on your answer to part A, is there a reason to doubt the manager's claim that the 3 people were selected at random? Explain. So this is the type of question you might see. Yes, the probability of selecting 3 women strictly by chance was only 0.012, which is much less than 0.05, which is our usual threshold for something that's unlikely to have happened by chance. So we'll conclude it was unlikely that the 3 women were selected at random. Part C, an alternative to calculating the exact probability is to conduct a simulation to estimate the probability. A proposed simulation process is described below. Each trial in the simulation consists of rolling 3 fair 6-sided dice, 1 die for each of the convention attendees. For each die, rolling a 1, 2, 3, or 4 represents selecting a man, rolling a 5 or 6 represents selecting a woman. After 1,000 trials, the number of times the dice indicated selecting 3 women is recorded. The question is, does the proposed process correctly simulate the random selection of 3 women from a group of 9 people consisting of 6 men and 3 women? Explain why or why not. And the answer is no, because each time you roll the dice anew, it's like sampling with replacement. So the probability of picking a woman for each trial is 3 out of 9, whereas the actual events required sampling without replacement. Next, we have 2018 number 2, an environmental science teacher at a high school with a large population of students wanted to estimate the proportion of students at the school who regularly recycle plastic bottles. The teacher selected a random sample of students at the school to survey. Each selected student went into the teacher's office one at a time and was asked to respond yes or no to the following question. Do you regularly recycle plastic bottles? Based on the responses, a 95% confidence interval for the proportion of all students at the school who would respond yes to the question was calculated as 0.584 to 0.816. Part A, how many students were in the sample selected by the environmental science teacher? So here is the formula for a confidence interval. Now you know the p-hat has to be in the smack dab middle of the interval. So to find that point, you're going to take the average of the 2 endpoints. So 0.584 plus 0.816 divided by 2 tells you that p-hat, your sample proportion, was exactly 0.7. So now you are going to calculate the margin of error. The margin of error is the thing to the right of the plus minus sign, which is indicated by this here. So z star times the square root of p hat 1 minus p hat over n has to equal the margin of error. So the margin of error is equal to either endpoint subtracting p hat. So we'll use the right endpoint, 0.816 minus 0.7 tells you the margin of error is 0.116. Now you're going to plug in 1.96 for z star since a 95% confidence interval, and you know p hat is 0.7, you're going to solve for n. So 1.96 times the square root of p hat, which is 0.7, times 1 minus p hat, which is 0.3, all over n is equal to the margin of error 0.116. Do some algebra, and you see that n has to equal about 59.95, or about 60 students. B, given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how the bias might affect the point estimate of the proportion of all students at the school who would respond yes to the question. Well, students had to respond personally and directly to the environmental science teacher, who presumably cares a great deal about the environment. Bias is introduced because students are going to feel pressure to say they recycle even if they don't. Imagine going to an environmental teacher's office and him asking you, hey, do you recycle? And you're probably feeling compelled to say yes. So the resulting point estimate is higher than the proportion that would actually respond affirmatively to the question. In other words, the 0.7 p hat is probably higher than the actual proportion of students that recycle. C. The stats teacher at the high school was concerned about the potential bias in the survey. To obtain a potentially less biased estimate of the proportion, the stats teacher used an alternate method for collecting student responses. A random sample of 300 students was selected, and each of the students was given the following instructions how to respond to the question. So in private, you will first flip a fair coin. If it lands heads, you will say no, regardless of whether you recycle or not. If it lands tails, you are going to respond truthfully. Yes or no? Yes, you recycle. No, you do not. Part 1. What is the expected number of students from the sample of 300 who would be required to respond no because the coin flip resulted in heads? This is as easy as it seems. Don't get fooled. Basically, you expect half the students to get heads. So 300 times a half is 150 students. Nothing more complicated than that. Part 2, the results of the sample showed that 213 of the 300 selected students responded no. Based on the results of the sample, give a point estimate for the proportion of all students at the high school who would respond yes to the question. So we expect 150 students to say no just because of the coin flip, which means 63 out of the 150 students we would estimate would say no truthfully, which means 87 out of 150 would have said yes. So 87 out of 150 comes out to 0.58. Now you might wonder why you would survey this way. Well, this way, most people are going to say no, but the environmental science teacher doesn't know who's saying no because of the coin flip and who's actually saying no because they don't recycle. So it protects the identity and the recycling status of the student, so they're less likely to lie to the environmental science teacher. Number 1 from 2018, the manager of a grocery store selected a random sample of 11 customers to investigate the relationship between the number of customers in a checkout line and the time to finish checkout. As soon as the selected customer entered the end of a checkout line, data were collected on the number of customers in line who were in front of the selected customer and the time in seconds until the selected customer was finished with the checkout. The data are shown in the following scatter plot along with the corresponding least squares regression line. There it is. Part A, identify and interpret in context the estimate of the intercept for the least squares regression line. So the 72.95, the constant coefficient, is the intercept. The interpretation is if there are no customers waiting in line, we predict that the checkout time to be 72.95 seconds on average. So remember to interpret the intercept. It's got to make sense in context, and here it makes sense to have no customers waiting in line. And the numbers have to also make sense compared to the scatter plot. You can't be extrapolating too far, and we saw other examples where there were no customers in line. So interpreting the intercept is entirely appropriate here. B, identify and interpret in context the coefficient determination, which is r squared. In previous years, they don't tell you what the r squared is. They pretend this wasn't here. And they would say, interpret the coefficient determination. That'd be a lot harder. But here they told you what it was. So r squared is 73.33%. Ignore the r squared adjusted. So that means that 73.33% of the variation in checkout time is explained by the linear relationship with the number of customers in line. Again, just remember the template for r squared. C, one of the data points was determined to be an outlier. Circle the point on the scatter plot and explain why the point is considered an outlier. So there it is, the one with 3 customers in line. And that customer had 3 people ahead of him, and it would have been predicted to be about a 600-second wait. But instead, that person waited only about 100 seconds, far below what was expected. So again, for an outlier, it's good to state whether the value was much higher than expected or much lower than expected, besides saying the dot is far away from everyone else. You want to be a little more specific than saying the dot is far away. You want to say that customer waited a lot less than what would have been expected. Finally, 2017 number 4. The chemicals in clay used to make pottery can differ depending on the geographic region where the clay originated. Sometimes archaeologists use a chemical analysis of clay to help identify where a piece of pottery originated. Such an analysis measures the amount of a chemical in the clay as a percent of the total weight of the piece of pottery. The box plots below summarize analyses done for 3 chemicals X, Y, and Z on pieces of pottery that originated at one of 3 sites, 1, 2, or 3. Part A, for chemical Z, describe how the percents found in the pieces of pottery are similar and how they differ among the 3 sites. So here is site 1 Z, site 2 chemical Z, and site 3 chemical Z. So one thing you can see right away is that the median is about the same for all 3 values, for all 3 sites, about 7%. But the ranges for Z are different. So at site 1, it's about 6%. At site 2, it's about 2%, and site 3 about 8%. Also, the IQR is similar at both sites 1 and 3, the width of the box, whereas it's very small for site 2. B, consider a piece of pottery known to have originated at one of the 3 sites, but the actual site is not known. Part 1, suppose an analysis of the clay reveals that the sum of the percents of the 3 chemicals X, Y, and Z is 20.5%. Based on the box plots, which site, 1, 2, or 3, is the most likely site where the piece of pottery originated? Justify your choice. So what you want to do is add up the minimums and maximums for each chemical at each site to get the total range for all 3 chemicals. So let's start with site 1. Site 1, the minimum for the 3 chemicals is 6, 11, and 4, so X, Y, and Z, which add up to 21. The maximum for the 3 chemicals is 8, 15, and 10, so the theoretical maximum is 33. For site 2, the minimums are 5, 2, and 6, which add up to 13. The maximums are 7, 4, and 8, which add up to 19. For site 3, the minimums are 5, 6, and 3, which add up to 14. The maximums are 7.5, 8, and 11, which add up to 26.5. Now, if you look at those sums, the most likely site is site 3, because it's the only site that contains 20.5 inside the sum, between the sum of the minimums and the maximums. 20.5 is too low for site 1 and too high for site 2. It fits in nicely where site 3 is, so that is the most likely site for this piece of pottery. B2, suppose only one chemical could be analyzed in the piece of pottery. Which chemical, X, Y, or Z, would be the most useful in identifying the site where the piece of pottery originated? Justify your choice. And it turns out chemical Y is the best choice. There's no overlap between the 3 box plots. There they are. So it'll be easy to pinpoint the likely originating site based on the percentage of chemical Y. Whereas the other 2 chemicals, X and Z, there's considerable overlap across the 3 sites. So that's set 2 for the combined FRQ. If you have any questions, feel free to ask me during office hours or send me an email.